Morning again, everybody. So, Dan Shearer on LumoSQL.
Hello. So this is a very new project, LumoSQL, and wasn't expecting to do this talk now. So I'm very pleased that we're getting I'm getting a preview of my own project. Can I ask to start with, who's heard of SQLite, uses SQLite, likes it, loves it? Yeah, right, so we are a SQLite in the room type place, good. So very famous, most people know what it's for, and we need to look at some things related to the history of SQLite and of another thing called LMDB. Anybody here heard of LMDB? So, not so many. We'll get to that. So SQLite's been around for a long time, since I think 2001, at least in a recognizable form. It was put out under the GPL version 2 license by Mr. D. Richard Hipp, who's still going strong at SQLite.org. And the basic premise hasn't really changed all that much in that time. And what he has always said, and still does, is that SQLite is a replacement for file open, the fopen system call. Slightly tongue-in-cheek, but what he's saying is that why not have a structured way of storing your data files locally? That's worth holding in mind, because we're going to come back to that. Life has moved on. So long after SQLite had made its mark and was in use at scale, there was a problem with key value stores. Now, a key value store is not a database. It's two columns. One has a key, and one has a value against that key. It's the classic computer science thing where there is a key, it's a value like name, and the value against that key is Bert, or Bertina. And so a key value store is a very simple data access facility at the bottom level of many, many things. There will be dozens and dozens of them on the average Linux distribution. One of the most common ones was the Barclay database, or BDB, and that was taken over or maintained by a group called Sleepycat. You may have heard of Sleepycat BDB, I guess it was called when you did yum install or apt-get install. And then Oracle bought them. And I think that was around about 2000 and maybe 12, 10. Oracle bought them and changed the license. And they changed the license so that if you wanted to use it commercially, you had to pay Oracle lots of money. And this thing was in everything. All of a sudden, there was a massive rush. What can we use instead? And it just so happened that a key value store that had been developed by Howard Chu of the OpenLDAP project was just waiting there ready to go. Almost the same API and had a lot of advantages. Interestingly, the advantages of the LMDB key value store hadn't been enough to secure adoption. It took this aggressive and pointless action by Oracle to get LMDB used in the vast number of projects that it is now used in. LMDB being essentially a key value store with a lot of really quite advanced features, which we'll get into a bit later. So I think this is maybe 2010, thereabouts. Someone with a web browser can correct me on that. And then LMDB is becoming quite famous. You'll find it in Samba, and which is quite a thing, because in Samba they built their own key value store called TDB, which was much, much better than BDB decades before. And many other high impact open source projects. 2013, Howard Chu popped up and he posted this. Just some quick benchmarks he'd done. What he'd done was take SQLite, and SQLite, of course, has at the bottom a key value store, and he was saying, look, I did a quick prototype of a rip and replace of my LMDB key value store instead of the one which is built into SQLite. License-wise, that wasn't an issue, because by this time SQLite was public domain. We'll get back to that one later on, where all of the authors, specifically Mr. Hip, mostly rather Mr. Hip, had said, we renounce all claim on this code and so forth. And so that was fine. And there's some quite substantial speed-ups being claimed there. Being Howard, being open source, the code was up there. Lots of people went, ooh, wouldn't it be nice to have a much faster SQLite? But for one reason or another, nothing ever happened with it. Bear in mind what I just said when we had Barclay database and the much superior, objectively much, much superior LMDB. Hasn't been adoption for a very long time until there was this non-technical external force for change. It seems like inertia is a powerful thing. And sure enough, after much wandering around and promoting of this, it is quite obvious. I mean, who wouldn't want a faster SQLite? Surely we should have a project. Surely everyone would dive in and all of that. It didn't happen. I spoke to Howard quite a bit about it at the time. He's presented at conferences. Anyway, he got busy. He's doing quite a lot of interesting things himself, which had nothing to do with this. Life moved on. I think he did some bug fixes in one or two of them in 2015. So we have then SQLite, LMDB, which is to be found in the Open LDAP source tree. It's a library. It just hasn't been separately packaged. Howard called his little prototype SQL Lightning. That was in 2013. And in 2019, I thought, no, that's enough, that's enough. Let's do this properly. And there's some really good reasons related to fixing the internet why this needs done properly. So I claim. So what I did was scratch my head and look at some source code and approach this lot that I highly recommend. It's a elderly foundation of the Internet Society type. They've been around pretty much since the beginning. You know, they were there, I think, before RIPE, if you're familiar with European internet allocations. And the EC recently gave them a chunk of money and said, go make the internet better. That's open to anyone in the room. You don't have to have qualifications. You have to have a good proposal. They do push back. They do challenge. And they do have some favorite things that they think will make the internet better. They would like to fit into that. It's about privacy. It's about robustness, things like that. However, they do a 3-month funding cycle. The next one closes February the 1st. I got in. I was quite surprised. I don't know, I've not quite done one of these before. So we got some modest prototyping funding. And so I found a gentleman in Belfast that I'd met at FOSDEM called Keith Maxwell, and together we've produced LumoSQL thus far. Now, what's the problem with SQLite? People love it. It's so simple. It does work. That is true. It also works for the use cases for which it's been designed and for which it is supported. And you can go to SQLite.org and you can look at the list of things that it says, these are good things to use SQLite for. And another list of things where it says, here's how you can corrupt a SQLite database. Who's experienced a SQLite database corruption at all, ever? Yeah. So, yes, it can indeed be corrupted. Who could be worried that they don't know whether they've seen a SQLite corruption or not? It ought to be everybody. It's an after-the-fact sort of thing. If something gets terribly broken, then yes, it got corrupted. But what if you didn't notice? So there's a few things there. The stakes are much higher now. SQLite was built for small things, or an application such as Firefox. The Mozilla people tell me that quite a few slowdowns and lockups they get are to do with waiting for SQLite to do things, because they use it extensively, and other browsers do as well. So it would appear there is something to look at here. As to SQLite.org and the code there, it's regularly maintained. It is, as far as I'm aware, just going as it is from now until infinity. It has Mr. Hip working on it. He's a highly skilled and loud advocate, as well as a highly skilled developer, which is important. However, some of these other use cases, multiple concurrency, high concurrency, it's not made for that. And we'll look at why shortly. And yet, increasingly, if you have a thing, an Internet of things, it's a pretty powerful computer, and it's doing lots of stuff at once, and we want multiple concurrency. That's where you can easily get corruption, for example, relatively easily. I'm not saying SQLite is bad. I'm saying it doesn't match the things very often that people use it for, which is a long, long way from a replacement for fopen. With me so far? That's my story. In essence, to NLNet was that this thing is at the bottom of a lot of stuff on the internet. In fact, you often don't even notice it in your infrastructure. Start looking into how configurations or even more vital information may be stored in a particular application, and you'll suddenly find there's SQLite. It's easy, it's simple, why not? So, the inappropriate or unsupported use cases, for that I will stick to what SQLite.org says, and we can look that up. We can go through that perhaps a little later on. Now, speed. This is what Mr. Chu was saying. I've got a much faster key value store, which he has, than nearly any of the alternatives. When I graphed it onto SQLite, it works much faster. He did a prototype, and that was that. I tend to believe Howard. He's certainly Mr. Benchmarking in the LDAP and database stakes. He's done a lot of it, reproducible stuff. If he says that, it sounds probably credible, but of course, then we need to reproduce it. Then there's the corruption issue. If a small sample set of this room, about half of you have seen a corruption and the other half could be worried that they've never seen one but might have had one. That's an issue. And then there is the matter of encryption, because we are in the modern internet, and having a database that does not come with encryption by default or available, that is an issue. There are EU laws, for example, that are pushing us this way. There was a talk about that yesterday, I believe. Now, I gave that one, in fact. So these are some of the basic things to look at. What can we do with that? Well, first of all, we did some code excavation. This is on GitHub. You can go and look at it yourself. It is now reproducible, but it surely wasn't. Going and finding code that probably worked in 2013, well, I'm sure it did work in 2013, but I don't know why it worked, and not all the upstreams were at all clear, and that is absolutely fine for a prototype. So that took some archeology. And then what principally for this particular thing, what my colleague Keith Maxwell did was develop a makefile and some scripts which would get a given version of SQLite and a given version of LMDB and put them together and then run the benchmarking, which was a cut down version of SQLite.org's official benchmarking. Just the speed and only about half of that. You can download and compile and try that today. The features benchmarking branch broke this morning. I didn't have time to fix it, or I'd show you right now. But that code is available for review. I was going to give it a couple more weeks, but there's a slot at the conference, and I'm giving a talk on it. So I guess it's open for criticism right now. You'll find a LumoSQL project on GitHub. Now, how the internal key value store works in SQLite really matters, because, like I said, SQLite is obviously a well-maintained project, regularly maintained project, and there is no way that I want to take on the burden of keeping up with what they do. So we have to find a way so that in successive future releases of SQLite, that an LMDB backend just continues to work and pass all of the testing and be suitable for production deployment. If this isn't a drop-in replacement of SQLite, then I've got something wrong. So found out the interface to the key value store, looked at the original port that Howard did, which was definitely according to prototyping rules, which says whatever hack works, do it. It now compiles as a proper library as opposed to just including LMDB source files, mdb.c. And there was some bugs to fix. So this was quite busy. And it was quite complicated, but we now have a makefile that will generate a nice little HTML page with a matrix of tests and some JavaScript that allows us to do simple comparisons as to how those tests are working. And I think it's pretty clear that our next steps on our way to a release are simple and hopefully less than a month away. Famous last words. That's what we're heading for. Now, another question that comes up if you're diddling around with the on-disk file format is what about backwards compatibility? What about migration? This is quite interesting because then the next question is, well, shouldn't we be able to use two backends, preferably two at once? The original one and the LMDB one. In fact, if we do it right, shouldn't we be able to put in a third one? And so that is very much a work in a development branch right now, is how can we make it so that we are both forwards compatible with SQLite going on, so that when they fix some bug with a select statement, we get that fix, and also completely compatible with the original key value store, and also completely compatible with LMDB underneath, so that we can go from old format to the new format, or indeed both of them at once, so that we have a new file and an old file. And also say that we don't know everything in the world. Maybe LMDB isn't the best ever. What if we want to put in another back end? So we need a nice generic thunking layer that doesn't interfere with SQLite code. That's what we're working on right now. And we have a, should we say, a prototype running? That's multiple backends. And finally, and this is one of the things that I pitched to NLNet, there are two features of databases, as far as I know, both open source and closed source today, that are really quite interesting because they don't exist. The first one is a very simple one. You heard what I said about integrity checking before. How do you know if your SQLite database has been corrupted? Indeed, how do you know if your commercial Oracle database is being corrupted? And the answer in both cases, at opposite ends of the complexity scale, I think Oracle is 30 plus million lines of code. SQLite is 275,000 lines of code. The answer is much the same. You have some third-party process running around doing integrity checks on the data file, nothing to do with your database at all. Certainly not visible to your application. Certainly not visible to your database internals. They do some basic integrity checking, like you go file open and is it gibberish? Well, you say corrupted file. However, you have no way of telling that what you wrote last Tuesday is what I read today. None whatsoever. We have a technology for this. You may have heard of the concept of checksums. For some reason, I do not know why, no databases I have been able to discover have an internal facility to checksum each row. Has anyone heard of this? I don't mean done with a trigger or a yes. Is there a database that does this?
There are some, but they're very esoteric.
Yes, there you go. So does this sound difficult? Does this sound a challenging concept? No, we've been doing this like for as long as there have been checksums. So I'm adding that in, that every row will have an internal checksum Potentially in the future, you would make that available also to an application via a SQL statement. Why not? But this checksum would be updated every time a row is written. Therefore, if you read a row and it doesn't match the checksum, ta-da! There are some issues with that, some performance issues, because normally, of course, checksums and encryption is done on a column basis in a database. I'm not saying it's easy. But for some use cases, for largely read-only rows, this is an integrity checking that will cost almost nothing. And I've checked with some database people, and they're going, oh, yeah. So I'm quite keen on that one. It's also simple. The next one isn't. And every mainstream database, every widely used database, mainstream is so loaded, does a 1990s way of concurrency called write-ahead logs. Postgres make a big thing of how their write-ahead logs are atomic files. But actually, the same facility, the same computer science technique is inside SQLite, is inside the database engine underneath MariaDB and MySQL, certainly Microsoft SQL Server, and so on. Databases are really, really, really conservative. So they should be. We need to get worried if people are getting too innovative with their databases. However, write-ahead logs for concurrency are really not the best approach in the modern world. What we have instead is the operating system offering to do a lot of this work for us. So we have a thing called a single-level store where the virtual memory subsystem on your operating system will allow you to view the entire computer's available space or available to that application as a nice contiguous space. And it will do things like concurrency if you do it in the right way. It will manage contention. It will manage corruption. Or rather, it will manage not to corrupt. Try very hard not to corrupt pages that have been swapped out to disk or that are in memory. You've got very clever people working in the Linux kernel or the other operating system kernels trying their damnedest to make sure that this virtual memory system is reliable and that you don't have to try and do it yourself with write-ahead logs. And that would be a step too far, certainly for someone who is definitely not a career database person, except we do have one instance of this at scale. LMDB already does this as a single-level store. It maps everything. It doesn't have little temporary files. Now, those that have used LMDB, do you have a feeling for how often you get corruption? Yes? More than zero, absolutely. It's got sharp edges. I'm going to take an unsubstantiated guess and say less than with SQLite or BarclayDB. And if you have a use case where that's not the case, last I heard, Howard takes this as a personal affront. Do go and shove it at him. That has been known to happen. So, for example, there have been people who've done fuzzing on not just LMDB, but other key value stores that results in corruption that isn't detected until runtime. And there's a debate as to how much corruption do you wish to detect. I'm not a decades-long database expert. I just use them, and I would have thought you want to detect a lot of it. But apparently there is database theory reasons why you want to detect corruptions at other levels. Is that a debate you're talking about? No? Okay. If you know more about these topics, please pop up and say so. I suspect you might. Excellent. Well, no, if you could enlighten the room if I've said anything atrociously wrong. But first of all, this business of write-ahead logs, the more I looked at it, and the more I compared with what LMDB is able to do, and one or two other really quite niche single-level store efforts that nevertheless do work, have convinced me that this is worth a go. There is not an obvious way of using LMDB to make rather, not an obvious way of using LMDB's single level store approach to make write-ahead logs go away, because these are at different levels. One is using key value store to implement the very details of where your SQL statements are making changes, whereas the write-ahead logs are very much to do with SQL transactions. So it's at a much, much higher level. Nevertheless, again, according to the design advice I've got from people who do databases at scale and for a living, this is very doable, and if we can pull it off, it will be the first SQL database at scale not to use write-ahead logs. That's a stretch goal, if you like. Definitely not for February 2020, but that's where it's going, or off a cliff. So far, what do we have? If I could just go back here. I'm about to take some questions before we go any further and draw on the expertise in the room. I'm trying to fix some things that are definitely going wrong for people who are using SQLite. There are no question that people are having issues with performance, with corruption. And for encryption, by the way, with SQLite, you may not be familiar with it. There is an open source patch set maintained separately that will give you a choice of, I think, 3 or 4 ciphers. I think that's right. And there is a much more extensive patch set available from the SQLite developers that you pay the money for. There is one other thing that isn't working, and I'm very conscious that I'm standing in Australia as I say this, which is the license. It was originally under the GPL, and it was then later on changed to be public domain. And there are 2 countries that you may have heard of where public domain is problematic. And one of them is Australia, where the question is that it's probably not valid, as I understand it, from the legal people. And the other is in Germany, where, as I understand it from the legal people, it is definitely not valid. So that's a problem right there. And so LumoSQL is under the Apache 2 license, which I'm at absolutely liberty to do. It's not a GPL, so you don't have to put the rest of your code under GPL if you use it, but it's not public domain. Also, Apache scoops up or is compatible with a sprinkling of other licenses that is in there. There's some hashing code in LMDB that is a public domain. There are some bits and pieces pulled into it as well, which are MIT. And LMDB is under an MIT-ish OpenBSD license. So that was the other thing that isn't working, which is definitely fixed in LumoSQL because that wasn't so hard. So that's what we've done so far. That's where we're going. You can see the code. We've got a lot more to do in the next few weeks. I look forward to that happening. And I'd like to take a pause on the talk there and hear from the room. A lot of people use SQLite. That means there's probably quite a few people here who know SQLite internals better than me. Let's hear it. I think if we're having questions that aren't at the end, I'm supposed to repeat them? No? Thank you.
Hi.
Hello.
Now it's on a microphone, so it's more dangerous. When you say hear from the room about these databases thing, what is it that you want specifically as feedback?
SQLite is fine for a lot of people. SQLite is too slow for many others. SQLite has issues. What do we have here? What feelings do we have in the room? Would you use a different, arguably better, definitely fully compatible, except for on-disk format, SQLite, if there was such a thing?
Okay, so background, I'm also another LDAP server author, so I've had a lot of experience with BDB, SQLite, these things, and LMDB. I've actually taken quite a look at the code and things like this. So the big one there is the ability to use it on a different host. So LMDB is affected by endianness order of your CPU.
Yes.
It is unable to be moved to other things, and it does have a fixed size file. You can never resize the database file after it's been created. So it can't grow or shrink, and it relies on sparse file handling with mapping. And I also think that there's no way to actually purge that later. So the main adoption risk you'll have is that it is very static, and a lot of the use cases for SQLite is its dynamic nature and ability to be transferred between hosts, such as metadata between, you know, a Yum repository for a client,
Yep.
or between different operating systems and which have different file system handlings and mapping, things like this. So this would be probably your barrier here.
That's good.
Yeah, so that would be my statement, is that because it is limited by the platform you're running it on, you may have barriers in adoption there, but that's just something to keep in mind and probably nominate or tell people about before they use it.
Okay, and there are a couple of other potential drawbacks as well. Hence, you heard me say multiple backends.
Multiple backends is good.
Yes, multiple backends are good.
So what's your impression on how open the SQLite developers are to enable you to easily drop in multiple backends?
On SQLite.org, it describes the project as not open. They will not accept patches. They've said that very clearly. However, they will review patches as a kind of a feature request. If you'd like to say, I'd like something that looks pretty much like what this patch set does, but they have said very clearly, they state on the website, they don't accept patches. So from that, you can deduce whether how open or not they may be. Certainly they chat on mailing lists. I'm sticking to their words exactly. Is that helpful? I mean, I could bring that up right now on the website. This is not controversial. It is a deliberate decision that they are a closed team. Does anyone have anything to add to that? I don't think I am saying anything that they do not themselves say. Yes, Robert.
This is more an LMDB portability question. I've just been looking at the equivalent for msync for Windows, and I can't see a blocking or async equivalent. So knowing that the data has been committed may be a challenge for you.
There's a further one. If you actually look at the LMDB code, they actually mix mmap and read-write calls in the default configuration.
They do.
Yes, so the readers are mmapped,
yes,
but the writers use a dirty write page cache in memory and use read-write calls. So you will end up with potential issues with, depending on your file system implementation and how it handles msync versus fsync between read-write and or mmap barriering on the VFS. However, there is a mode you can turn on which forces everything to be mmapped always, even the reader-writers, to avoid that.
So there is a lot of sharp edges in LMDB, and some of these sharp edges are of the nature that if you didn't read the documentation or you didn't read the function header, then and you use it in a sharp-edged way, it will crash. And that's not seen as a bug, because to protect against that would not meet the goals of LMDB as the author sees it. So there are certainly lots of things that people say are cons about LMDB, but I do want to emphasize that what LMDB did was move on the state-of-the-art of key-value stores very significantly. In a very small amount of code, initially about 5,000 lines, now a bit more, we have full MVCC, that is multiple version concurrency and control. We had, that basically means lots of writers at once, writing lots of writing threads or processes rather than lots of clients on the internet, just to be very clear. That was a really significant advance on BDB. Even experienced people at the back there, I think, have to agree with that. There is another thing too. I have to remember when it came out that this is an extremely conservative area of file storage, computer file storage, and changes are not made lightly. Now, I am one of the founders of the Samba project, and one of the things that Tridge found he had to do pretty early on was invent a thing called TDB. And TDB was a bit idiosyncratic, but it was a lot better and a lot faster and a lot more reliable than BDB. And that was kind of a benchmark for a long time. And then it's been replaced in the Samba project with LMDB. And I think that was very clearly an advance on the technology. I'm not suggesting that LMDB is the end of the road. In fact, the more I look at it, the more I think there are things that could be done. I know that Howard has published his ideas for a version 1.0. It's currently sitting at 0.9. You also heard me say multiple backends. So what I'm trying to do is build something that will meet use cases that are immediately useful, that are API compatible, and that kind of unlock the potential of SQLite to go into a high volume, rather modern Internet of Things, possibly, who would know, actually interneted Internet of Things, because clearly SQLite is made to be not networked at all. To do that, I think there has to be some steps. The first step I can see is to implement a better key value store. There are some architecture issues on both sides of that divide. SQLite has definitely got some architectural issues in how it deals with its underlying store. Looking for contributors. Yes, at the front.
Thanks very much for the talk to begin with. Have you considered alternatives like LevelDB or RocksDB?
Yes.
And how do they compare?
So they tend to be a bit more niche. There are, in other words, I can expect that BDB, for all that it's had a license change, LMDB, and these others, I can put them into pretty much any C or C++ project I like, or indeed Python wrappers. LevelDB, and by and large, I can be fairly confident it's going to be more or less okay. There will be some corner cases, there will be perhaps some crashes, there will be some API issues, maybe. RustDB and LevelDB, I don't have that degree of confidence. I've found too many cases where there's been an effort to put it underneath some generic pieces, some widely used piece of software, and performance drops very significantly, or there are portability issues. There are portability issues, as has already been stated with LMDB, but they are relatively niche. If you are staying in the nice, safe playground of conventional Intel servers, you will not see any of the issues that are raised at the back there. Does that sound like I've given a good answer to the gentleman at the front? Okay, thank you. There is just one other thing. I wanted to go to my very last slide. I am conscious that one of the reasons I am here is because there's been a very unusually high dropout rate of speakers in LCA to do with bushfires. And I'm not going to speculate whether that's why this slot is empty or not, but generally speaking, that's the case. That is a shot from a place in South Australia where I was brought up. Yarrabee Road. Has anyone heard of Yarrabee Road? Yeah. You remember Yarrabee Road, 1983? I was a teenager. I was there the next day for various reasons. The road was razed. There was terrible loss of life, not a house standing. It's also famous because there was a state radio broadcaster who lay down at great risk to his life. He was trapped there under his front fence, and he live called his house being destroyed. That is a shot from Yarrabee Road. I guess there's a lot of people feeling the pain, but that was about as bad as it could get. And I will never forget how awful it was. And yeah, there's a nice little flower and lots of greenery. So that is my talk. Are there any further contribution questions? I think we've got, what, 3 or 4 minutes to go? Good. Yes. Another question at the back.
So jumping a bit higher level, probably one of the more interesting features about SQLite is it's just a file open. So all the controlling code runs in the SQLite library in each process that's using the database. It really limits the writers when you've got multiple processes trying to write to it. Oh, can't really. So have you thought about alternatives for how to use the database besides just a file open?
Right, so you're talking about the case where we've got multiple processes. Let's pick Firefox as like the classic well-known case. That would be an extension, say, in Firefox that is storing data in SQLite, and there are multiple threads within that extension that want to have want to open SQL transactions at once. Is that what you're saying? Indeed. So your point is that concurrency can happen at multiple levels here. I was talking about concurrency at lower levels in the SQLite and LMDB stack. You are talking about a higher level, often evaluates out to the same thing, I think. SQLite does this already, but at risk. What it says on the website and on the mailing lists are that for low volume concurrent SQL transaction calls, it's probably fine. For high volume, it's not. And that's one of the things I'm trying to fix. Some of that lack of robustness is in the not very strong logging, write-ahead logging and locking code at the bottom. Write-ahead logging being here. Bottom level, key value store concurrency being under there. Neither of those are particularly robust as far as I can see. I believe that fixing those are likely to address the problems that you're talking about, which the Mozilla people tell me are probably why Firefox is getting lockups in certain cases with certain extensions. So the answer is yes, I have thought about it. Clean up the code path, and I think some of that will go away. Anything more than that, I don't know yet. Please jump in.
You mentioned using the multiple backend thing to deal with traditional file format to LMDB migrations. But I assume you'd be able to use it for other migrations as well, like encrypting an existing database and that sort of stuff? Is that on your radar?
Exactly. I would very much like to think that is the case. I'd also like to think that it will also turn SQLite into its own integrity checking tool. Because, I mean, who hasn't been contacted by a relative that says, I've got a corrupted file in my Microsoft something. And you say, oh, file save as ancient version, file open save as new version, and all of a sudden it goes away. I mean, it's a little bit like reboot the computer, right? But there is something to it. So I would like to think that the multiple backends will be fully functional and intended to be used both concurrently and in series. That is, batch mode translates and record by record translates. So yes, I can't think of any other reason why you would do this.
Just a quick question. Regarding the testing of your implementation, I mean, I would kind of imagine that seeing that there are a lot of users of SQLite, that there will be a much wider, I mean, testing would be a giant job just by itself.
Okay.
Because I would imagine, you would need to actually have a lot of combinations of underlying file systems, particularly because of the range locking and the sort of synchronization mechanisms that happen at the file level, especially between multi-process writers. And then the different file systems.
So you're saying, indeed, you're saying on disk formats, you're saying probably by order, and you're saying timing issues, which means
so
caching.
Not necessarily the format, but a lot of the multi-process synchronization happens by like range locking, for instance, and flock and the equivalent, you know, on the different platforms. So you have different mechanisms for, you know, Windows.
Let me tell you my secret master plan initially for version 1 testing, right? And this partly comes from NLNet. Who's heard of Nixos? Nix, Nixos, or the Nix package manager, which, yeah, okay. So there are two things about it. Number one is the way it manages its libraries is basically via symlinks, which means that if you want to slide in an API-compatible library across your entire distribution, it's actually really quite easy. And so the notion of being able to go full operating system load test with SQLite and then full operating system load test with LumoSQL is very attractive, and Nix makes that easy. But the second thing is that Nix itself, the Nix package manager, uses SQLite underneath. I'm not 100% sure why it should, but it does. They chose to do that, and they work it very, very hard, and there are particular search strings and so forth that I can use to demonstrate that it's just dying with a leg in the air. So at those two levels, I think Nix is a really good initial test bed for this, particularly given that you can install Nixos on multiple file system types without a great deal of problems. So you can see the testing matrix that opens up using the goodness that is Nix as your test tool. That's my secret plan. Internet love Nix, and so because they reckon it make the world better. So there you go. That's my first. Anyone got a problem with that? Can you advance on that, improve on it?
Well, no, because like LMDB only allows single writer and parallel reads anyway, so you don't have to worry about range locking. So that's the entire test case you don't need to worry about, but there are other things. But my actual question is, you talked about consistency and verification of data. LMDB does not do this.
Nope.
LMDB only guarantees certain behaviors with copy on write. Are you planning to add integrity checking, as in check something into LMDB, or are you planning to do it at the higher level so that any future backend for SQLite will gain integrity checking of the key value store and or pages you're writing out?
So here's my logic so far. Normally speaking, I would say if I've got a SQL database, then I would like to put encryption in at the SQL type level, not at the key value store level, because that's just wrong. However, integrity checking and encryption, you know what? They're really, really similar. And it seems to me that for that reason, it makes sense to put in encryption in one layer down and then get integrity checking for free, or maybe vice versa. That is my fingernail sketch architecture so far. What do you think?
Only if you're using an authenticated encryption. And that would be your important to clarify that one, but otherwise, yes, that is an option.
We've got to find stepping stones to a better future rather than designing some amazing thing. We are open source software here. We know what happens when we try and design an amazing thing.
I think that's, I think we're, time's up.
Okay, so who's going to do the LumoSQL BOF starting right now outside? All right, I'll go out there so we don't sort of hassle the next speaker.
Here's a little gift from the organisers.
Thank you very much. I've got one for each hand now.
Yeah. So, and can everyone just give Dan a call?